Hey everybody, today we're working on part 2 of the final exam review, so we're going to jump right in. My goal is to get through about question number 26, but we're going to find out just how far we can make it. All right, so we're going to start with number 15. We have been given two functions. How does the graph change? We have been doing this since chapter 1. Look, I know this one is a log graph, but it doesn't actually matter. All of the transformations that we have been doing have been consistent the entire way through. So if I were to tell you this second graph was transformed down 4 units, I think you would probably believe me. Okay. Now, the other thing you need to see is the -3, but the negative and the 3 do different things. The 3 itself is a vertical stretch with a factor of 3, whereas the negative in front of it is actually a reflection about the x-axis. So that's what you need to consider when we're going through these problems. The negative in front of the number actually does something different. So you actually get a different result from this and the negative. Okay, so there were 3 things that changed. I would say the exact same thing about question number 16. You're talking about a graph that went up 5 units. Now, whenever we're doing trig, we start using the trig language. We start saying that the midline would be y equals 5. Now, depending on your teacher, I'm not sure what they want you to say in this situation, but just be ready. It's a final exam, so be ready for whatever they write. Whenever we are doing a vertical stretch, in this case the factor was 2, we don't actually, in trig language, call it a vertical stretch with a factor of 2. We would then add to the story something about the amplitude being 2. Okay, the amplitude is just your distance from the midline to the highest part of the graph, or the lowest part. Okay, and then last but not least, the same thing as last time, we have a reflection about the x-axis. All right, let's roll on here. Now, this was one of the ones where if you were given one of the answer keys for this final exam review, the answer key was wrong, but we're going to work through it anyway. Now, we've got, let's see, we've got a bunch of different interest formulas. Rumor has it you're going to be provided with some of them, but either way, you should probably keep track of what's going on. All right, so what we have here is a starting amount of 600. The annual interest is only 1.4%, which quite honestly, that's pretty lousy, but that's okay. We'll just move on. Okay, there you go. 1.4%. You have to move the decimal over twice, so you get 0.014. And it is being compounded monthly. That means 12 times per year. Now, whenever you're doing one of these formulas, you do need to make sure you put the 12 in 2 different places. You need to put it down there, and you need to put it up there. Okay, now there are a lot of different ways to handle this problem. For me, I am going to use whatever graphing calculator you feel comfortable with, because that's just my preference here. We're going to roll through that. We're going to put that in parentheses there. And I'm going to say x instead of t. Okay. Now, the question said, how many years will it take you to have a value of 1,000? So what we actually want to do is put this equal to 1,000 and see how long it takes to get there. So in this particular case, I am going to make a second graph that just says 1,000. And then I'm going to change my window to get this thing right. X is the number of years because we're using x instead of t. I think this is a pretty terrible investment, so I'm going to go out 50 years because I think this might take a while, and I'm going to put tick marks every 5. For my y, I need to try to find a way to get up to $1,000, so I'm going to make my scale go up to 1,200 just so I can get a really good view of what's going on. All right, so Let's see. Did I make a mistake here? I think I did. All right. Let's see. All right, so we've got that. We've got that. I can't believe I made a rookie mistake on my own presentation. That was awful. Folks, did you notice what just happened there? I did not put the 12 and the x in parentheses, so I got the answer wrong. Oh my goodness, please don't be like me when you grow up. Anyway, all right, so we're gonna go through here. We're gonna see how long it takes to make this thing happen. Okay, second calc, intersect, then you hit enter 3 times, whatever your calculator does, whatever method your calculator uses. It says round to the nearest tenth, so I am going to say it takes 36.5 years. So again, yeah, that was awful. Please don't make that mistake. On these calculators especially, they are using the order of operations. They're not doing anything wrong, but I got my answer wrong because I did not put the 12 and the x in parentheses. So the calculator raised it to the 12th power and then just multiplied by x, which was obviously not what you were supposed to do. Okay, so that was awful. I sincerely apologize. Okay, let's move on. All right, number 18. For which value of x is the equation true? Check for extraneous solutions. This is one of my favorite types of problems because if you have the same log on both sides, then you can pretty much just ignore it and just solve for what's inside. That means you're turning this into a basic algebra 1-2 equation, like a little two-step equation where you just subtract 4x from both sides. And then you've got 4 equals x minus 1, and then you could just add 1 to finish the deal. And you would get x equals 5. Now you do want to check your answers and make sure you get something that makes sense because you can't take the log of a negative number. So you would want to go back, you'd want to plug in 5 for x here, and you'd want to plug in 5 for x here. You would get 24 on both sides, the log base 2 of 24, which means that checks out. There is nothing extraneous about that. All right, now this one, we've got 2 or 3 problems here that are just the most obnoxious problems on the review, and you need to just know that sometimes it's okay to just do your best and move on. In fact, if this were a multiple choice question, I would be very, very tempted just to plug in numbers and see what happens. But I'm going to show you the right way to do it, and you can make the decision for yourself about whether you like it or not. All right, so whenever we are combining 2 logs that are being added, you're allowed to use multiplication. So I'm going to combine these using multiplication. I'm going to use kind of some nested parentheses going on here. Technically, I should be using brackets, but I don't feel like it. All right. Now, whenever you are rewriting a log in exponential form, all you have to do is take the base of the log and make it into the base of your exponent, and then the other 2 pieces just switch places. And then this will go down here. Now, as I am writing it, I am going to distribute because I just don't like the way that is written. So I'm going to distribute the x all the way through there and there. 4 to the 3rd power is 64. And if I am trying to solve a quadratic equation, which is something we did way back in the day, but we can't forget how to do it, I am going to have to move the 64. I'm going to subtract 64 from both sides. So that's going to leave me with a 0 over here, and it's actually going to leave me with something that factors over here. Because if I'm looking for 2 numbers that multiply to give me negative 64 and add to give me 30, I can actually find them pretty easily. It's actually 32 and negative 2. Now, whenever we are solving a factored equation over here, you can just look at each piece. So if I just focused on the x plus 32, how would I solve that equation? Well, I would have to subtract 32 from both sides. So that would mean x equals negative 32. And then if I were to try and solve x minus 2 equals 0, I would add 2 to both sides, so x equals 2. It did say to, on the previous question, check for extraneous solutions. If you went back in and you plugged in negative 32 for x, that would not work. It would be extraneous because you would be trying to take the log of a negative number, which is a no-go. So I would actually throw this one out, and then I would just say x equals 2. And if anybody asks you why, you would say x equals negative 32 is an extraneous solution, as in you plug it in, you tried it out, it didn't work. So x equals 2 would be the solution they are looking for. Okay. All right, number 20, a pie with a radius of 7 inches is cut into 10 equal sized pieces. How long is the arc of a piece of the pie? So basically, if you were to go down to the middle and just cut out one piece of pie, what would happen? Now, there are two distinct ways of doing this, but I am going to base my explanation on what we learned in the last chapter about arc length. We learned that arc length is the radius times whatever your angle is, okay? Now, there's a catch. Okay. The catch is that trick only works if you are in radians. So what I'm going to do is I'm going to think about this angle, and I'm going to think of it in terms of radians. 10 equal sized pieces. Well, if you've got 360 degrees in a circle and you're cutting it into 10 pieces, that means each piece of the pie is 36 degrees. And if I were to change 36 degrees into radians, every 180 degrees makes a pie. So I am going to quit out of my previous graph. I am going to do 36 over 180. Leave the pi alone because your calculator cannot frac a pi. And I would get 1/5. So that means the radius is 7, and the angle, put the pi back now, is pi over 5, 1/5 pi. Which means my arc length is 7 pi over 5 inches. It did say decimal to the nearest 1 decimal place, nearest tenth, so I am going to throw it in the calculator. I'm going to do 7 pi divided by 5, 4.39, so I am going to say that the answer is 4.4 inches. Again, there are two different ways to do arc length. There's one that we usually talk about in geometry class, but I wanted to go with the one that we did most recently. Okay. So feel free to pause if you're falling behind, but we're going to keep rolling here. Convert the following angle measures to degrees. So we actually just got practice changing degrees to radians. Now we're going to go the other way around. So instead of pi over 180, we're going to go 180 over pi. Notice that when you do that, the pi's cancel out. And again, the reason we're doing this is every 180 degrees is 1 pi. I've also taught it previously that every 360 is worth 2. Either way, it doesn't really matter. However you slice it up, it's going to get you the answer you're looking for. 390, there you go. We'll try again. We're going to do times 180 over pi. Same idea. We're doing that because we want the pi to go away. Anybody who wants the pi to go away, just put it in front of me on Thanksgiving. As long as it's not pumpkin pie, the most overrated of all pies. Do not fight me over this. All right, there you go. 420, ha ha, ha ha. All right, we're going to go 11 times 180 divided by 18. 110 degrees. There you go. All right, we're going to go on to 22. I was originally the kind of person who did not want kids to memorize the unit circle. But as soon as I found out how good kids were at getting it right, I gave in. You should memorize the unit circle. You should take a few minutes on your final exam and sketch it out on some scratch paper, because cosine of 225, if you actually memorized your unit circle, you know that it's the first number right here, and it's negative radical 2 over 2. So again, I was the person who said we shouldn't memorize it until I realized that it could be done and kids were actually doing really well. Okay, so there's no excuse. Get it done. Negative 60, sine of negative 60. So now we're going to work backwards 60 degrees. And then sine is going to be the second number in the ordered pair. So negative radical 3 over 2. All right, last but not least, tangent of 120. So we're going to go to 120, and then tangent is sine over cosine. So you've got to take these two numbers and divide them. So radical 3 over 2 divided by negative 1/2. Now, we talked about this before. The 2's really just cancel out, because if we were to flip and multiply, the 2's would really just end up 1 on bottom, 1 on top. It wouldn't matter. So what you would really end up getting is just the square root of 3 divided by negative 1, which is just negative square root of 3. There you go. All right, once again, we're moving quick, so if I'm moving too quick, pause the video. 3 pi over 4. That is 135 degrees, but if you know your unit circle, you don't have to do anything. All you have to do is go to 3 pi over 4. Sine is the second number. Sine always shows up second, so you get radical 2 over 2. Okay, same thing here. Cosine of 5 pi over 3. If you know your unit circle, then you know that that's 300 degrees. And cosine is the first number, which would be 1/2. So we're going to go and we're going to call that just 1/2. All right. Tangent of 7 pi over 6, that is going to be 210 degrees. So we're going to go over here, 7 pi over 6, 210. This one, we have to do a little rationalization, which I'm sure you're thrilled to death about. So if you take negative 1/2 and you divide it by negative radical 3 over 2. Again, the 2's cancel out. Tangent is sine over cosine, but the 2's cancel out. A negative divided by a negative is a positive, so it's really just 1 over radical 3. But remember, the fine folks in math land decided that you cannot write a final answer that has a radical in the denominator, so we need to do that trick. It's called rationalization. If you are trying to figure out what's going on here, you can Google it, but you need to put math as part of your Google search, because people can rationalize anything. So if you don't specify what type of rationalization you're looking for, Google will not help you. All right, there you go. We got that, we got that, we got that. All right, 24 and 25 are not going to appear on your unit circle, so you're going to have to do actual work, okay? So be ready for that. All right, sine is negative 7 over 25, and pi is less than theta, which is less than 3 pi over 2. Now, all of this is only there so that we can look on our unit circle and know that it has to be somewhere between this and this. So when I am sketching out the triangle that I'm about to sketch, I am going to put the negative 7 here, and I'm going to put the 25 here. Because again, sine is opposite over hypotenuse, and I know from this that it has to be in quadrant 3. And I have to draw it because obviously that is not on the unit circle. Okay, now cosine is adjacent over hypotenuse, which means we have a missing side that we have to find. Now, I would like to think that you would know it because we have done some of these Pythagorean theorem problems a lot, but if we're being honest, I'm assuming you don't. And that's okay. We'll go through the process. Not a big deal. Okay, we're going to subtract 49 from both sides. That's going to give me 576. And it turns out that that is a perfect square, and 24 squared is 576. Now the catch is we are in quadrant 3. We are moving to the left. And if we are moving to the left, that means that 24 is negative, which means the cosine of theta is negative 24 over 25. Okay. All right, now that was a long one. That was another one of those that I know is going to be one of the most commonly missed questions on the final exam, so just watch the video 3 times if you have to. We'll get it right. All right, 25, same concept, but I'm just going to operate in quadrant 1 because they did not tell me to do anything different, okay? Now, 0.9 is the same as 9 over 10. So when I am sketching out a triangle, and again, the reason I am sketching out the triangle is because they did not, you cannot find 9 over 10 on the unit circle, okay? Now that means, once again, we have a missing side. So I'm going to have to do a little bit of Pythagorean theorem business, just like that. All right, there you go. All right, we got that. B squared is 19. So that means 19 is not a perfect square, so I'm going to have to just put radical 19, which means the cosine of theta is the square root of 19 over 10. All right, now, this is another one of those problems where if you are using their answer key, you're going to notice something weird. They wrote square root of 0.19 on the answer key. I would never write it like that in a million years. I'm just being honest with you. But I want to show you what they did real quick. What they did is they decided to be smart, and they said, hey, 10 is the same thing as the square root of 100. And their logic was probably, hey, since we wrote the initial question with a decimal, we should write the final answer with a decimal. And 19 over 100 is 0.19. Again, I would never have done that, but be on the lookout. It's a multiple choice test with a little bit of fill in the blank. Figure out what they are looking for and make it happen. Okay? All right, last but not least, a gardener calculates that each tomato plant he planted last season grew a mean of 9 pounds of tomatoes. The standard deviation is 3 pounds. So this is one of those problems where we did the normal distribution. So basically, we put the mean in the middle, and then we made intervals of 3 pounds. What is the probability that a plant will produce at least 6 pounds of tomatoes? So if the standard deviation was 3, that means I am counting by 3s. Okay? Now, what we learned is that if it is a normal distribution, then 50% of this is going to be over here, and 50% of it is going to be over here. So the probability of getting at least 6 pounds of tomatoes means every value from here on. That would be at least 6. Now the catch is that 50 breakdown is not enough of a breakdown to answer this question. We have to get into the nitty-gritty of these details here. So this was when we had to break it down a little bit more, and we did the 34 and the 13.5 and the 2 and the 0.5. Those are the 4 numbers you just sort of had to memorize as you go. So if we know that there's 50% over here, there's a 50% chance that it's going to be more than 9, and then we add in the other 34% that we got from this area right here, you would get 84%, or if they are looking for a decimal, you would call it 0.84. I'm not sure which answer they're going to be looking for, but either one is good. Okay, I hope that helps you along. Good luck to you. Stay tuned for part 3 on Monday. Thanks a lot.